Good evening everyone. Good evening. Good evening everyone. Yes, today's class, first problem. Can you see this problem? Let M be the encoding of a Turing machine as a string over sigma is equal to 0, 1. Let M is equal to M, where M is a Turing machine that accepts a string of length 2014, then L is, right? So can you see this problem? What is the answer? Yesterday we tried, because of some unavoidable reasons I am unable to continue, right? Can you see this? Can you see this now? Can you see this problem? Let M be the encoding of a Turing machine as a string over sigma is equal to 0, 1. Let M is equal to set of Turing machines that accept a string of length 2014, then L is decidable and recursively enumerable, undecidable but recursively enumerable, undecidable and not recursively enumerable, decidable but not recursively enumerable. Can you see what is the answer of this? I am going to give answer. First you try. It is a really nice problem. This may come in the exam. Similar kind of problems may come in the exam. Check one time. So what he is saying is, careful everyone, right? So this is a Turing machine. Listen, this is the Turing machine. This Turing machine will accept all those strings, right, whose length is 2014. Means to this Turing machine, if you give 2014 as in 2014 length string, if you give, it will go to halt final. To this Turing machine, if you give 2014 length string, it will go to halt final. If you give more than 2014, if you give less than 2014, right, it is a invalid. Invalid means, you know, in the case of Turing machine, if you give the invalid, it may go to final, it may go to halt non-final, it may go to hang also. So 2014, there is a clarity. 2014 if you give, right, it will say yes, means what is the meaning? Halt final it will go. If you give other than 2014, if you give other than 2014, means if you give 2013, if you give 2010, if you give 5, if you give 2015, if you give 2030, sorry 2060, something like that. So if you give invalid, means if you give the no strings, they will go to halt non-final or they will go to hang. If you give invalid strings, it will go to halt non-final or it will hang. So means what I want to say, there is a chance of hanging also. Suppose assume that yes also no hanging, right? No also no hanging. Yes also no hanging, Y also no hanging, that is called recursive, means decidable, right? Yes also no hang means decidable, no also no hang decidable, then it is called recursive, means decidable. Suppose assume that yes no hanging, Y hanging is there, that is called recursive enumerable. But remember, right? So yes is no hanging, right? No is a hanging, that is recursive enumerable. Suppose that yes also no also, in both the places a hanging possible. Yes also no also, in both the places hanging possible, that is going to be undecidable. Okay, I am repeating once again because I said right, I said undecidable, some wrong thing. Let me check once again, right? So if you give the valid thing, it will go hang. Valid thing hang. valid thing hang possible, that is called, right, that is called completely undecidable. Valid thing, right, hanging, valid thing hanging, that is called undecidable, completely undecidable. Valid thing not hanging, invalid thing hanging, that is going to be recursive, but that is also undecidable. So finally what I want to say, 2014 if you give, which is the valid, right, hanging, right, halting finally is possible. 2014 if you give, which is the valid thing, halting final possible. If you give other than that, it may halt, may not halt. It may halt, it may not halt. That is the reason it is a undecidable, but remember it is a recursive enumerable. Because valid thing it will halt. Valid thing also don't halt, then it is going to be undecidable. It is undecidable but recursive enumerable, which is also called as semi-decidable, Answer is undecidable but recursive enumerable, B. Similar kind of problem may come, please verify. Right, in examination they may say, right, accept a string of length 2014. Right, it is going to be recursive and recursive enumerable, right, and undecidable also. Right, suppose if they give 2014 by, right, 2014 by 60,000, then also same story. 5, that is also same story. Right, 3, that is also same story. Any number, that is also same story. Right, please careful. Valid things, right, halting final. Invalid thing, anything can happen. So it is undecidable but recursive enumerable. Anyone having any doubt, please let me know. It is a very nice problem. It may come in the exam. So you can say from Rice theorem it is true. What is the Rice theorem? Any non-trivial property of Turing machine is undecidable. What is the non-trivial property here? If you give valid, it will say halt final, means yes. If you give invalid, you cannot say the behavior. If you give invalid, you cannot say the behavior. You can say the behavior, that is called as the trivial. You can say the behavior, that is called trivial. Non-trivial means you cannot say the behavior. Right? Any non-trivial property of Turing machine is undecidable. So if you see the invalid things here, we cannot say the behavior. So non-trivial property is there. Any non-trivial property of Turing machine is undecidable. Right? So that is the answer for this. I hope people got this. Let's go to next problem. Can you see this? What is the answer of this? Try. What is the answer of this one? Can you verify one time? Yeah, I given enough time. Now let's see the answer. I given enough time, let me see the answer. See this one. Which one of the following statement is false? 1. Halting problem of a Turing machine is undecidable. True. True, using Rice theorem, right? Non-trivial property of a Turing machine is undecidable. What is the meaning? If I give some string, right? If I give some string on the given Turing machine, right? After reading that string, Turing machine may halt, may not halt. Anything can happen, right? Anything can happen. To the given Turing machine, if I give some string, it may halt, may not halt. So it is a non-trivial property of a Turing machine is undecidable. Yeah, it's a well-known theorem, everyone know that. Go to the B. Determining whether a context-free grammar is ambiguous or not. Right? This I think it is very difficult. So it is not a non-trivial, it is not a trivial, it is a non-trivial, everyone know. So this is going to be once again undecidable. It is also undecidable. It is a well-known, these two things are well-known things. And next one, given two arbitrary context-free grammars G1 and G2, it is undecidable whether L of G1 is equal to L of G. This is called equality. Equality of, right? Equality of CFL, which is undecidable. Next one, given two regular grammar G1 and G2, it is undecidable whether L of G1 is equal to L of G2. What is saying? Which one of the following is false? Given two regular grammar G1 and G2, it is undecidable whether L of G1 is equal to L of. Remember, two regular means are two DFAs or two finite automatas. Two finite automatas are equal or not is decidable because there is a using comparison table you can compare both are equal or not. So it is actually decidable, but he is saying undecidable. That is the reason false. Right? So using comparison table you can compare two finite automatas are equal or not. Finite automata means regular grammar. Finite automata means regular expression. Finite automata means DFA. Finite automata means N of A. Finite automata means epsilon N of A. Many ways are there. Regular grammar, regular language, finite automata, DFA, N of A, regular expression, right? Next one is going to be, right, epsilon N of A. So many ways. So many ways. Remember, these are the standard statements. These are the standard statements. And one more thing, those people who are watching, right, if you didn't attend my classes, right, so there is a closure properties, one table is there. Closure properties, one table is there, right? That table, if you read, I have a table, right? If anyone want, you can ping me, I will give that table. Closure properties, one table there. If you see that table, if you by heart, you will get minimum 2 marks, right? If you want that table, ping me, I will give that table. One table is there, closure properties, where decidable, undecidable problems are there, and remaining things also there. All I kept in one table. If you want to ping me, I will give that. This is my WhatsApp number, you ping me. Right? So some standard thing here, nothing to do, standard things, these are standard. In this problem something there, but in this is the standard thing, right? Fine, let's go to this. This is also came from standard. Can you verify at least now? Can you verify at least now? Yeah, can you try this? These are the standard things. This is also standard things. Can you check once? Yeah, check one time. are the standard things. This is also standard things. Can you check once? Yeah, I will give the answer. Let's try. Which of the following are decidable? Which of the following are decidable? 1. Whether the intersection of two regular languages is infinite or not. Whether the intersection of, see the intelligent way of giving. Whether the intersection of two regular languages is infinite or not. Right? So infinite of regular, right? Infinite checking, infiniteness of or finiteness of regular is decidable. So indirectly, directly same, right? Like that only. So it is decidable. Normally finiteness of regular is decidable. It is almost similar. Instead of saying finiteness, he said infiniteness. When it is not finite, it is infinite. So it is the same story, right? Different way of asking. And one more, he said intersection of two regular languages. We can do intersection of two regular languages using Cartesian product. Using Cartesian product, we can do intersection of two regular languages. Using Cartesian product, we can do intersection of two regular languages. After doing Cartesian product, you got the finite automata. On that, you can apply finiteness algorithm, which will goes to, right, decidable. Next one, whether a given context-free language is regular or not. Whether a given context-free language is regular or not. He is not saying context-free grammar. He is saying context-free language. Right? So whether a given context-free language is regular or not, no one can say. It may be, may not. Non-trivial property. Next one, whether two push-down automata say accept the same language. Right? I think equality of PDA. Right? So undecidable. Next one, fourth one, whether a given grammar is context-free, right? Whether a given grammar is context-free or not. Right? Whether a given grammar is context-free, very simple. Grammar is talking about grammar. If any grammar is given, if you want to check a context-free, go left side, just check left side everywhere single variable. Right? Fourth one is decidable. So in my opinion, answer is 1, 4. Which of the following are decidable? It is a really nice problem. First one, fourth one decidable. Whether a given grammar is context-free or not. Take the grammar, go left side of the arrow symbol, everywhere single variable, context-free. So it is a trivial property. So anyhow, first one, fourth one is a decidable, remaining are undecidable. What is the second one? Context-free language is regular or not. No one knows. Whether two push-down automata are equal or not. No one knows. So 2, 3 is undecidable. 1, 4 is decidable. 1, 4. Answer is B. It is a very nice problem. It is a really nice problem. Someone is saying fourth is membership. Fourth is a membership. No. Fourth is not a membership, but it is decidable. Fourth is not a membership, but it is decidable. See, whether a given grammar is context-free or not, it is not a membership. It is not a membership. So can I go to next problem? Please check. Anyone having any doubt, let me know. Right. So before going further, let me say something about Unacademy. So those people who are watching, right? If you don't have Unacademy learning app in your cell phone, please download. If you don't have Unacademy learning app in your cell phone, please download. After downloading over, scan this QR code. You are able to find out so many free classes which are very quality classes. Just scan this QR code, you will find out so many classes which are free and quality also, lot of quality also there. Please use it. Next one, next one, next one. See everyone now, see everyone. Algorithm is just started. Algorithm data structure just started. Algorithm data structure just started. My suggestion is please join in that. Please join in that as soon as possible. Algorithm data structure is just started. Please join in that as soon as possible. Use the referral code ReddySir. Use the referral code ReddySir. Next one, you can join plus also, you can join iconic also. If you go for plus, four advantages. If you go for iconic, so many advantages. I think approximately double advantages. Next one, there is a 20% off offer is going on. In Unacademy, if you want to join, 20% off is going on. This is valid till July 22nd only. This is valid till July 22nd only, right? My suggestion is use the referral code ReddySir, join as soon as possible. Next one, price hike is going to be happen very soon. Price hike is going to be happen very soon. So if you want to be winner, right? Using this code, you join as soon as possible. You will get 20% discount. 20%. After some time, if you do, right, you will get a very less discount, right? So please utilize this. I hope this is useful to you. Let's go to the next problem. Yeah, this is the next problem. Can you see once? Try what will be the answer for this. Yeah, let's see the answer. Almost everyone tried. Let me give the answer. Which of the following problems are undecidable? Which of the following problems are undecidable? First one, deciding if a given context-free grammar is ambiguous. Right? You cannot. Undecidable. Deciding if a given context-free grammar is ambiguous. Next one, deciding if a given string is generated by a given context-free grammar. Membership problem, decidable. It is membership. Deciding if a given string is generated by a given context-free grammar. This is called membership. Lalit, this is called membership. Lalit, are you getting? This is membership. Deciding if a given string is generated by a given context-free grammar. It is called decide. It is called as membership. Next one, deciding if the language generated by a given context free grammar is empty. Emptiness problem of context free. It is also decidable. Emptiness problem of a context free. This is also decidable. This is also decidable. Next one, deciding if the language generated by a given context free grammar is finite. This is also decidable. Deciding if the language generated by a given context free grammar is finite. This is also decidable. This is also decidable, right? I think answer is asking which one of the following problems are undecidable, or which one of the following problem is because of only one. Which one of the following problem is undecidable? Answer is A. Answer is A. Which of the following problem is undecidable, right? I think option A. I think option A. I think option A. Option A. Right. So remember, undecidable problem. If you see all my classes from the last 1 week, if you see undecidable problems, many I covered. All of them study one time. All of them study one time. If you want to know that chart, one table is there. If you want that table, right, you can ping me. If you want that chart, you can ping me, right? So from the last 1 week, I said so many problems. Please practice all of them. Please practice all of them, right? Let's go to here. What is the answer of this problem? Can you check? It's one more problem. Try this. Yeah, let me give answer. Whatever you got, it's okay. Let me give. Which of the following problems are? Which of the following problems are decidable? Let's check. Does a given program ever produce an output? Right? When I write a program in computer, if I run it, it may produce, may not produce. Sometime it will go to infinite loop. It's a really nice problem. This is called membership problem. Sorry, this is called halting problem of a Turing machine. Everyone know computer program is nothing but Turing machine. Computer program is nothing but Turing machine, right? So I have a one program, I run it, whether it will give output or not. It may give, may not give, it may halt also. It is a halting problem of your Turing machine, which is undecidable. Next one, if L is a context free language, then L complement also context free. If L is a context free language, then L complement also context free. No one knows. Maybe, may not. Undecidable. No guarantee. No guarantee. If L is a regular language, then L complement also regular. Exactly. Exactly. Decidable. If L is regular, L complement also regular. Exactly. Next one, if L is recursive, then L complement also recursive. Exactly. So if you see the option, right, which are decidable is asking. Decidable. Please clarify once again. Don't pick blindly. Right, before going to give answer, please recheck again. Decidable. I think decidable 3, 4. Decidable 3, 4. So D is the answer. Decidable 3, 4. D is the answer. Undecidable 1, 2. Some people may select undecidable because they like undecidable. They don't bother what the given problem is. They like undecidable, they will select. They like, right? They like, right? Undecidable, they will select. They don't worry about what the given problem is. So remember, this problem is asking decidable. Answer is D, 3, 4. Answer is D, 3, 4. Next one, can you see this one? Consider the following sets. Consider the following sets. S1, set of all recursively enumerable language. Yeah, first you try, afterwards I will give answer. If I give directly, no use to you. First you try. Try once. Try once. If I give directly, you don't get any advantage. You try once. Set of all recursively enumerable languages over alphabet 0, 1. Set of all recursively enumerable languages over the alphabet 0, 1. Set of all syntactically valid C programs. Set of all languages over the alphabet 0, 1. Set of all non-regular languages over the alphabet 0, 1. Which of the following are uncountable? Uncountable means one-to-one mapping not possible. Set of all recursively enumerable languages over the alphabet 0, 1 means set of all Turing machines. Recursive enumerable languages, yeah, it's perfect. It's a countable. Set of all recursively enumerable languages are countable. Next one, set of all syntactically valid programs. I think S1, S2 same. S1, S2 same. That is also countable. One-to-one mapping possible. Next one, set of all languages over the alphabet 0, 1. Set of all languages is same. Set of all languages over the alphabet 0, 1 is 2 power sigma star. Language means sigma star. Set of all languages over the alphabet 0, 1, that is going to be uncountable. Set of all languages is uncountable. Set of all non-regular languages also uncountable. Non-regular language, non-CFL, right? Next one is going to be non-CSL. Next one is going to be non-REC, right? Next one is going to be non-REL. I am repeating once again. Who are the uncountable? Set of all regular language, set of all languages over the alphabet 0, 1. That is undecided, right? That is uncountable. Non-regular language is uncountable. Non-CFL is uncountable. Non-CSL is uncountable. Non-REC is uncountable. Non-REL also uncountable. So what is the answer for this? Can you see the option? Can you verify? Even I didn't see, right? Let's check. I'm thinking whatever I said, right? Perfect. Let's see. I'm trying this. So what is the first one? What is the S1? What is the S1? Countable. S2 countable. S3 uncountable. S4 uncountable. Is asking uncountable. I think answer S3, S4. B. Excellent. Excellent. B is the answer. B is the answer. S3 is uncountable. S4 also uncountable. It's a really nice problem. Please take care. It's a really nice problem. Please take care. Answer is S3, S4, which is uncountable. Set of all recursive enumerable languages are, right? They are countable. See, set of all regular languages are countable. CFLs are countable. CSLs are countable. RECs are, set of RECs are countable. Set of RELs are countable. But complements are not countable, right? Remember S1 countable, S1 complement is not countable. S2 countable, S2 complement is not countable. S3 itself is not countable. S4 itself is not countable. Answer is going to be S3, S4 are uncountable. So if you want to get a clear clarity, in plus course one class I said about the countable, right, uncountable. One class I given, 2 hours lecture. 2 hours lecture will give clarity. Otherwise it's very difficult. In plus class 2 hours lecture I given. Just 2 hours lecture I given. So please careful. Please careful. Right, now go to the next one. What is the answer of this problem? Yeah, so let's see once. Consider the following problems. L of G denotes the language generated by a grammar G. L of M denotes the language accepted by a machine M. L of G denotes the language generated by a grammar G. L of M denotes the language accepted by the machine M. Right. Fine. So some statements are given. Let's check. For an unrestricted grammar G and a string W. Unrestricted grammar G and a string W. For an unrestricted grammar G and a string W, whether W belongs to L of G. Unrestricted grammar means what? I think everyone know Turing machine. Unrestricted grammar means Turing machine, right? String W, whether W belongs to, I think it is a membership problem, right? Turing machine membership problem undecidable. Turing machine membership problem undecidable. Next one, given a Turing machine M, whether L of M is regular. Given a Turing machine M, whether L of M is regular, maybe, may not, right? Undecidable. Next one, given two grammar G1, G2, both are equal or not. We don't know which kind of grammars. They may be unrestricted grammars. They may be two CFLs. They may be two CSLs. They may be two REC. They may be two REL. Right? So we don't know. So undecidable. Until now all are undecidable. Next one, given an N of A N, whether there is a deterministic PDA P such that, right, P and NP accept the same language. I am repeating once again. Given an N of A N, given an N of A N, right, whether there is a deterministic PDA means DPDA such that N and P accept the same language. So can you help me? What is the meaning of this? Deterministic PDA such that N and P accept the same language. N of A N. For N of A is there means, listen, N of A is there means DPDA also there. So for the given N of A, draw DPDA. Two DPDAs are equal or not. There is a algorithm. It is a very nice point. Fourth point is a nice point. N of A N, DPDA P. You want to verify both are same or not. Very simple. N of A N, right? Convert into DPDA, because for every regular DPDA possible. Now check two DPDAs are same or not. So, right? DPDAs are equal or not. There is a equality DPDA decidable. So answer is going to be, is asking, what is asking? Can you see this one? What is asking? Consider the following problems. Yes. Which of the following statements are correct? Right? Which of the statements are correct? Remember, 1, 2, 3 are undecidable. Fourth one is decidable. Let's see option A. 1, 2 are undecidable. Only there. Remember here, only there. Remember. Only 1, 2 undecidable. No. Only 3 undecidable. No. Only 3, 4 undecidable. No. Only 1, 2, 3 undecidable. Yes. Check properly. Yeah, someone is saying that, but in the third one, in the previous problem, someone is saying third one. Yeah, this one. Yeah, here maybe. Can you see the third one? Given two grammars, which grammar? Right? Whenever you don't mention the which grammar, so you can take any one, right? Take the larger one. How can you take smaller? If you take smaller, I will say that it is fail for something else. So remember, when you don't mention, take the larger. Larger one is unrestricted grammars. So when you say third one is true means for every grammar it is true. Given two grammar G1 and G2, whether L of G1 is equal to L of G2, I cannot say everything, right? Sometimes it is possible, sometimes not possible. One fail also, fail only. Third one, sometimes possible, regular possible. For other grammar, not possible. One case fail also, fail only. One case fail also, fail only. Please careful. Yeah, can you see this? What will be the answer for this? Yeah, what is the answer for this? What is the answer for this? Let sigma be a finite non-empty alphabet and 2 power sigma star be the power set of sigma star. Which of the following is true? Let sigma be a finite non-empty alphabet and 2 power sigma star be the power set of sigma star. Which of the following are true? Sigma star 2 power sigma star countable. Sigma star 2 power sigma star countable. No. Sigma star 2 power sigma star uncountable. Right? No. Sigma star countable, 2 power sigma star uncountable. Exactly. Sigma star uncountable, 2 power sigma star. No. It is a nice problem. Please take care. It is a nice problem. Please take care. Right? Fine. Now, can you see this? What is the answer of this? Arey Akhil, don't waste time. Instead of typing, right? Why you waste time? Give answer. Don't waste time. I given some time so that you will solve. Why you waste time by writing no? Don't waste time. You are wasting time. So can you say what is the answer of this? Try answer of this. I have given some time. Verify. Let L of R be the language represented by a regular expression R. Let L of G be the language generated by a context-free grammar G. Let L of M be the language accepted by a Turing machine M. Which of the following decision problems are undecidable? So can we say what will be the answer for this? L of M be the language generated by a context-free grammar G. L of R be the language generated by regular expression R. R is regular expression, G is the context-free grammar, and L of M be the language by Turing machine. So remember, R for regular expression, G for the context-free grammar, M for the Turing machine. Right? Fine. Then which of the following problems are undecidable? Which of the following problems are undecidable? Right? Can you check one by one? What is the A? What is the one? given a regular expression R and a string W where W belongs to L of R, right? Regular expression, membership problem, decidable. Regular expression, membership problem, decidable. Next one, given a context free grammar G, L of G is pi, right? Context free grammar, emptiness, decidable. Next one, given a context free grammar G, L of G is sigma star, right? Context free grammar, totality for some alphabet sigma. For some alphabet sigma, this is called context free grammar, totality. So what is the answer? This is undecidable. Context free grammar, totality, undecidable. Next one, given a Turing machine M and a string W, membership, undecidable. So I think 1, 2 decidable, 2, 2 undecidable. Sorry, 1, 2 decidable, 3, 4 undecidable. What is asking? Which of the following are undecidable? Undecidable is these two people. 3, 4. Where is the 3, 4? 3, 4. Answer is D. Answer D. Answer D. Answer D. Ayush is saying don't waste time. You are not given answer. If you give answer immediately, then I will say you didn't give an answer. Right? You didn't give an answer. First you give answer, then say. If I give the answer, if I give the problem, if you give answer immediately, then I will say maybe I am wasting your time. You didn't give an answer. Ayush, you didn't give an answer. Akhil, you didn't give an answer. Without giving answer, how can you say, I given some time so that you will try? Yeah, try this problem. The following finite state machine accepts all those binary strings in which the number of ones and zeros are respectively. The following finite state machine accepts all those binary strings in which the number of ones and zeros respectively. So this is the automata given. These are the options. Right? This automata, number of ones what? This automata, number of zeros what? Check. This automata, number of ones what? Number of zeros what? Can you verify? Option A, right? Number of zeros divisible by 3, number of ones divisible by 2. B, zeros odd number, ones even number. C, zeros even number, ones odd number. D, divisible by 2 and divisible by 3. Remember, first one is zeros. First one is ones. Second one is zeros. Try properly. So can you check the first option? Ones divisible by 3, zeros divisible by 2. Ones divisible by 3. Check 1 divisible by 3. So if I give 0 ones, accepted. If I give 3 ones, accepted. 6 ones, accepted. Right? And so on. And so on. And so on. Can you help me now? What about this? 1 0 1 1. 1 0 1 0 1 1. 1 0 1 1. But right, zeros are divisible by 2. 1 0 0 1 1. Exactly. I think option A. Option A. Option A answer. Answer is option A. Verify. Verify. Answer is option A. Verify. Right? Number of ones divisible by 3, number of zeros divisible by 2. If you want, you can give 2 zeros, 4 zeros, 6 zeros, 8 zeros. Number of ones divisible by 3, 3 ones, 6 ones, 9 ones, and so on. And so on. Perfect. Answer is A. Do the manual checking. Do manual checking. Do manual checking. Do manual checking, you will get the answer. Someone is saying odd even, no, no. Odd even, no. It is I think it is a Cartesian product, right? Product automata. This is a product automata. Divisible by 3, 3 states. Divisible by 2, 2 states. Right? End operation, right? A's, right? Ones divisible by 3, 3 states. Zeros divisible by 2, 2 states. If you do Cartesian product, it will become 6 states. I think same thing, same thing. Same thing. Answer is option A. Answer is option A. Fine, perfect. Yeah, can you see this? Can you see this? Give regular expression for the language L is equal to exactly 2 A's over the alphabet AB. Give regular expression for the language L is equal to exactly 2 A's over the alphabet AB. Give regular expression for the language L is equal to exactly 2 A's over the alphabet AB. Someone is saying why not B, go there. Why not B, go there. Right? Ones are odd. Ones are odd and even. Zeros are even. See. Ones are odd. Zeros are even. Zeros are even. Let's check. Ones are odd. You are saying, see this one. 1, 2, 3. 4, 5, 6, right? 6 ones are there, accepted. How odd? 6 ones are there. 1, 2, 3, 4, 5, 6. See, 6 ones, not odd number. How it is accepted? Arey, can't you cross check? Ishani, can't you cross check? 6 ones accepting. 6 ones accepting. How odd number? 6 ones accepting. How odd number? Ishani, can't you verify? Can't you verify one time? Yeah, perfect, perfect. Now go to the next one. Give regular expression for the language L is equal to exactly 2 A's over the alphabet AB. I want regular expression for the language L is equal to exactly 2 A's. Exactly 2 A's over the alphabet A comma B. Can you check once? Regular expression for exactly 2 A's. Exactly 2 A's means, listen, exactly 2 A's means 2 A's you write. If you want exactly 2 A's, write 2 A's like that. But what about B's? What about B's? May come, may not come. If they come anywhere, they can come. May come, may not come. If they come anywhere, they can come. May come, may not come. If they come anywhere, they can come. So this is the answer. May come, may not come. Anywhere they can come. I want 2 A's. Perfect. Right? What about B's? Anywhere can come any number of time. Anywhere can come any number of time. Go here. At most 2 A's. At most 2 A's. What is the meaning? At most, maximum 2 A's. Listen. Maximum 2 A's. A plus epsilon. A plus epsilon. Maximum. Maximum. So if you want, you can take epsilon here. If you want, you can take epsilon here. So epsilon will come. Then if you want to 1A here, here epsilon. If you want 2 A's, 1A here, 1A. So possibilities are there. What about B's? Same. B's can come any number of time, anywhere. B's can come any number of time, anywhere. B's can come any number of time, right? Anywhere. Now, at least 2 A's, at least 2 A's. See this one, at least 2 A's. A plus means minimum 1A. A plus minimum 1A. A plus minimum 1A here, minimum 1A. Here you can take 1 lakh A's also. Here you can take 1 lakh A's also. What is the next one? B star. This is the answer. A plus you can take any number of A's. Minimum 1A guarantee, minimum 1A guarantee. B's can be anywhere, any number of time. Someone is saying, why singing? I am singing. Palas bud area saying that hello sir, right? Hello sir, why singing? Do not sing. Arey Palas, I am singing. Brainless fellow, right? So I think this is the answer for this. At least 2 years. At least 2 years. This is going to be at most 2 years. This is going to be exactly 2 years. This is the very right. This is the very important. These three people, please learn properly. These three people, please learn properly. Please learn properly. Yeah. What about this problem? Can you check? Yeah. Can you check this problem? It is a nice problem. Someone is saying how AB will generate in which problem? How AB generated in which problem? Someone is saying at least 2 years, minimum 2 years. Someone is saying minimum 2 years. Yeah, I think yeah, whatever he said, correct. Yeah, it's a nice one, right? Thank you so much for asking. Right? So I think the problem here is right, whatever years extra coming, they are coming continuously. Whatever years they are coming continuously. They are coming continuously. So need not be continuous. I think yeah, that is the reason some counter example is came. So this is the answer for this, right? Listen, this is the answer. A plus, that is fine, right? In between you can write happily like this: a plus b whole star, a plus b whole star, a plus b whole star. Now no problem, right? Now no problem. Verify. Thank you so much. Satyam, thank you so much. So this one, I think that is the problem. That is the thing what the Satyam pointed out. Thank you so much. So this is the answer. Now Satyam, now verify. So in the previous answer what happening is A's are coming continuously. Yes, coming continuously. Now I think this problem not there. Thank you. Satyam, you can verify now. Satyam, I thought that people are sleeping. Let me write whatever I feel. Anyhow, people are sleeping. No one is listening. I thought let me write whatever I feel. I written. Thank God. Satyam is listening. Satyam, you are listening. Thank God, one person is listening. Thank you so much. Right, perfect. Let's go to next problem. Can you see this? Yeah. So what is the answer for this? Remember, listen, remember this. Let the language accepted by M be L. Let L1 be the language accepted by a N of a M1 obtained. So listen, this is M. Language accepted is L. Next one, and one more is drawing, M1. Language accepted is L1. So but how to get M1? Very simple. Here non-final, make it final. Here non-final, make it final. Here final, make it non-final. Right? Fine. That is the thing what is said. See, let L1 be the language accepted by the N of A M1 obtained by interchanging that accepting state of M to non-accepting state and by changing the non-accepting to accepting state. Yes, remaining things are as it is. Here 0, 1. Here 0. Right? Here 0, 1. Remaining things are as it is. Here 1. Here 0. This is starting state. Here. Now he is asking which of the following statement is true. If you observe clearly in this diagram, if you observe clearly, epsilon accepted, 0 accepted, 1 accepted, right? 0, 1 followed by anything accepted, 0 or 1 followed by anything accepted. Indication that it is, I think in my opinion, answer is 0 plus 1 whole star. L1 accepting everything, L1 accepting everything, L1 accepting everything. Now come here. L1 is equal to 0 plus 1 whole star. That is right. L1 is equal to 0 plus 1 whole star. Because L1 accepting epsilon 0 or 1 or 0, 1 followed by anything. So answer is right. L1 accepting 0 plus 1 whole star. Answer is option B. Answer is option B. Option B. Verify. Someone is saying that L1 is equal to 0 plus 1 whole star minus L. No. L1 is everything. Verify. Satyam, right? L1 is everything. L1 is everything. If you want, I will say one thing. See this one. L1, listen. L is accepting 1. L1 also accepting 1. See. L1 also accepting 1. So both are accepting, right? Both are accepting 1. Then how can you say L1 is 0 plus 1 whole star minus L? How can you say that? There are some common things also there. Remember, right? L1 is everything. L1 is everything. B is the answer. If you say L1 is sigma star minus L, means nothing should be common. No, something common also there. If you want, I will say one more string. In the given, right? In the M 0 0 accepting. Here also 0 0 accepting. In the M 1 0 accepting, right? 1 0 accepting. So many things are common. But right, M1 is accepting everything. Right? Today if you observe, I said many problem. Today if you observe many problem, it is the first problem. It is the second problem. It is the third problem. Many problems I done. It is the fourth problem. It is the fifth problem. It is the sixth problem. It is the seventh problem. It is the eighth problem. It is the ninth problem. It is the 10th problem. It is the 11th problem. 12th problem. 13th problem. Yeah, here tricky problem. Please take care. So I done initially some small mistake. Thank you Satyam. Thank you so much for identifying. 13. Next one. It is the 14. Right? 14 problems I done. Today I done 14 problem. Really all are important. All are nice. All are very nice problem. Please go through it one time. I hope this class is really useful to you, right? So if you want to connect with me, you can call, right? You can WhatsApp me to this number, right? And those people who want to join in Unacademy, right? Those people who want to join in Unacademy, see, algo data structure is going on. It is really useful to you. My suggestion is join as soon as possible. 20% offer is going on. 20% off offer is going on. Satyam, right? If you didn't join Unacademy. It will be really useful to you. Satyam, if you didn't join till now, you can join in Unacademy, right? Attend all the plus classes, right? Possibility of getting rank is more better. More possibilities are there if you take subscription and if you attend all the plus classes, right? Satyam, it is, if possible, you can join, right? If you are not joined, if you already joined, I am very happy, right? Thank you so much, right? See you tomorrow, right, at the same time. Thank you so much.